Right, so we're going to be going over some coordinate geometry of the circle questions. So here we are. Question 3, it says, the circle C has equation x squared plus y squared minus 2x plus 8y plus k is equal to 0, where k is a real number. And then it says the radius of C is 5 root 3. Find the value of k. Doing any question like this, you just got to look at it and think, all right, what formula is going to actually use? So I can't, or it doesn't make sense to use anything involving the equation of a circle, because this whole thing is an equation of the circle. It just has a variable in it. And there's no formula for an equation of the circle which just gives you whatever the constant value is. So we got to look at what else the question gives us. So it tells us that the radius is going to be equal to 5 root 3. So I'm going to have to look at what my radius formula is. So if I go to my tables, I'm going to see this page right here, everything to do with the circle. As I said, this doesn't really help us with anything, neither of these do, because it's just going to be the equation of a circle. So you need to have your center, which is your h and k, and then you need to have your radius. Tells us the radius. It doesn't matter what x and y are, but we don't have the center of it. But we do if we look at the question, but it doesn't help us find whatever that extra value is. So instead, I'm going to be looking at this one here. We have the equation circle in this form, so we're looking for C. So I have to use something here to find this. Tangent at the point x1, y1 doesn't make a difference. The center doesn't make a difference, but this one involves a C. So I'm going to be using this equation for the radius of a circle to plug everything else into, and that's how we're going to get it. So here we are. We're going to be using the equation that g squared plus f squared minus c, find the square of that, is equal to the radius, and we know that the radius in this case is going to be 5 root 3. So now we need to just plug in the values. So g and f are going to be the center, and it's going to be, now we need to figure out what g and f are. To find out what g and f are, we're going to look at the coefficients of x and y when the highest power is 1. So we ignore the squares and we ignore everything else. So we're just looking at these values right here, and we're just going to divide each of them by minus 2. So we have minus 2x divided by minus 2 is just 1x. So my g is equal to 1. And then we do the same thing for 8. So we do 8y divided by minus 2 is equal to minus 4y. So f is equal to minus 4. And I just plug these in. So I'm going to find the square root of 1 squared plus minus 4 squared minus c, and that is going to be equal to 5 root 3. So now that I've tidied all that up, how do we get rid of this? Well, we're going to square both sides. So then we're going to get, so inside this bracket, first of all, if we simplify it, we're going to have 17 minus c is equal to 5 root 3. Square both sides, we're going to get 17 minus c is equal to 75. But then we're just going to bring the c over here and the 75 back over here. So then we're going to end up with c is equal to minus 58. So in this case, we know that k is equal to minus 58. And that's going to be your answer. So if we go on to part B now, it says the circle x minus 5 squared plus y plus 2 squared is equal to 20 has a tangent at the point 9 minus 4. Find the slope of this tangent. So you can sketch it out, or there's a formula for the tangent at a point, but all we care about is the slope. So if we were to sketch this out, we know that the center of this circle is going to be at 5 minus 2. So it's going to be somewhere here. And then if we just draw any circle, doesn't have to be the most accurate thing, it's just to get a rough idea of it. We know that this is going to have a tangent at the point 9 minus 4. So if we say that, say the point 9 is, say, here, and then minus 4 is going to be somewhere here, let's just say, then we know that this tangent is going to happen here. So it'll look something like this. So we can say, or we can tell first of all, that this is going to have a positive slope, because it's the only way I can touch it and make a tangent with it. Then we also need to look at, right, if I draw my radius from the center to here, this is 90 degrees, or it's perpendicular. So if I can find the slope of that blue line, I can just flip it and that'll be the slope of the red line. So how do I find the slope between that? Well, we know the center is going to be the point 5 minus 2, and we know that this point down here is 9 minus 4. So you can use a slope formula, you can use, it doesn't really make sense to use the equation of a line formula because you need the slope for it, so you'd have already figured that out. So I'm literally just going to be using the slope formula. So I know that m is equal to y2 minus y1 over x2 minus x1. So using this formula, I'm going to call the blue line, I'll change this to blue, just to keep the colours going. So I know that the slope of m1, which is the blue line, or from the radius to that tangent point, is going to be y2, which is minus 4, minus 2 plus 2, and that's going to be over x2, which is 9, minus 5, and this comes down to minus 2 over 4, which is just minus a half. So then if we're finding m2, which is the red line, we just flip that. So it's going to be perpendicular slopes, we just flip the fraction and change the sign. So we put the 2 on top, the 1 on the bottom, and then we change it to a positive. So then we're going to get plus 2 over 1, which is just 2. So we know that m2 is going to be equal to 2. And that right there is going to be our slope. Next, part C says 2 circles each have both the x-axis and the y-axis as tangents, and each contains the point 1 minus 8 as shown in the diagram on the right, not to scale. Find the equation of each of these circles. It may seem a bit daunting at the start because we don't know what the centers of these circles are. We don't know the intersects, so that can't be. If we knew where it intersected the x and y axis, we'd be able to find the center. So we're gonna have to think a little bit outside the box. So if we go down here and just sketch out what one of these might look like. So I'm just going to do this for the bigger circle, but it doesn't really make a difference. And we put that touching the x and y axis. So if a circle has tangents on both the x and y axis, we're going to be able to find the center, but we're going to have to find it sort of algebraically, rather than we're not going to get a nice whole number for it. So if we call the center right here, and we think about what the center actually is. Well, the center is equidistant from every other point. So if I were to draw a line from the center straight across, otherwise the radius, it would look something like that. And then I can also do the same thing going straight up. And if you think about this, the center here is going to be 1 radius length across and 1 radius length down. So we can call the x value, so from here to here, is going to be equal to this line right here, which is going to be the radius length, and it's going to be a positive radius length. So I can call this distance r, and we can use the same reasoning for this bit right here. As it goes down 1 radius length, it has to be here 1 radius length down. So I can call this one then minus r. So that's going to be the radius of that. And we're going to be able to use this and a few other facts about circles to solve the rest of this question. So, beside of it, we also know that the equation of a circle can be written in this form, where you have x minus h squared plus y minus k squared is equal to r squared. And then we can just start plugging in values. So, it tells us that on this circle, if we look back up, we have this point, which is going to be 1 minus 8. So if I do a rough sketch of where this is right now, I can say right here is the point 1 minus 8. Otherwise, I have an x and a y value. I don't have my center, but I can write my center in terms of the radius. So I can rewrite this as my x value is 1 minus the x value, so 1 minus r squared plus y is going to be minus 8, and then my k value for the y coordinate of the center is going to be minus r, so it's going to be plus r squared, and this all equals r squared. And I'm going to use this to help solve for both of them. So this is going to give me a quadratic, which I'll show you in a second. One of the values is going to be the radius for the larger circle, and the other one's going to be for the smaller circle, which we'll see now in a second. So here we are. Now we just expand the brackets. 1 minus r squared, well, that's going to be r squared minus 2r plus 1. And then we're going to have to add on minus 8 squared is 64 plus r squared, and then we're going to have minus 16r. And then this is going to equal r squared. Now we just add both the sides, so we have 2r squared minus 18r plus 65 is equal to r squared. Sorry, that should be 65. and now bring this r squared over to that side. So then we're just left with r squared minus 18r plus 65 is equal to 0. You can use the minus b formula, or you can factorize this. So we have the roots of r, or the factors of r are r and r. Factors of 65, I know 13 and 5. I know that because if I do 13 times 5, I get 65. And if I combine 13 and 5 to be positive or negative, and then add or subtract them from each other, I'll get minus 13 minus 5 gives you this minus 18 right here. So we know that's going to be r minus 5 and r minus 13. So r is equal to 5 and r is equal to 13. So if we look back at the picture, or we look back up here actually, we're going to have this bigger circle. It's going to have our center here and here, which is 13 and minus 13. So therefore my center is going to be 13 minus 13. And if we look at the smaller circle, it's going to be here and here. So we have 5 and minus 5. So my center is going to be 5 minus 5. I don't need an x and y value because it's not required in the formula. So if I use this equation again, what I'm going to end up with for r is equal to 5, I'm going to get x minus 5 squared plus y minus minus 5 is plus 5 squared is equal to, and then 5 squared is 25. And then for r is equal to 13, I'm going to get x minus 13 squared plus y plus 13 squared is equal to 13 squared, which is 169. So although it looks daunting, these questions come up every so often. If you just know them off by heart or you're used to seeing them, it's handy marks, because you literally just plug in your radius as plus and minus r. It gives you a point, so that's going to be my x and my y. Then we're just going to multiply everything out. We're going to end up with a quadratic. Solve said quadratic using the minus b or factorizing, and then just sub these back into the original formula in replace of h and k, and then we leave x and y as is. We also plug it in for r as well. So that's how you do that question. So question 4, it says the diagram below shows a triangle ABC not to scale. The coordinates of each point are given. Part 1, show that the circumcenter of the triangle ABC is the midpoint of AC. So if you haven't done any constructions yet, the circumcenter of a circle is going to lie on the midpoint of the hypotenuse. So if we look at this triangle and we assume to begin with that this is right angled, it means that the center of the circumcircle, or the circumcenter, is going to be somewhere around here. Otherwise the midpoint of the hypotenuse, which is this one right here, and this is if we draw this triangle, which just looks like this is a right angle right here. So how do we prove that? 2 ways we can do it. First of all, we can find the midpoint of what we assume to be the hypotenuse. So if we assume this is the hypotenuse, we find the midpoint from A to C or C to A. And then we find the distance from, well, it has to be the same distance from here to here and to here. So then if it's also the same distance to B, this is going to be the circumcenter. Otherwise, we can prove that these two lines are perpendicular to one another. And if they're perpendicular, it means their slope is going to be flipped around. So if they're perpendicular, it means that this is a right angle. So the circumcenter has to lie on A to C. So we're going to do it that way. So first of all, we need to figure out our slope. So if we look at this, we're going to have our slope, or write them out, we're going to have A is 8,4, C and B minus 3,2, and B is going to be 5,8. So I'm trying to prove that CB is perpendicular to BA. So if I find the slope, I'm going to need my y2 minus y1 over x2 minus x1. And then we're going to find the slope from C to B first of all. So if I find the slope, that's BC, this is going to be equal to y is 8 minus 2 all over 5 plus 3, which is going to be equal to 6 over 8, which simplifies down to 3 over 4. Now we find the slope BA, or AB. this is going to be equal to 4 minus 8 all over 8 minus 5, which simplifies down to minus 4 over 3. And to prove that they're perpendicular, if we multiply one slope by the other slope, it should equal minus 1. Otherwise, I'll have m1 times m2 is equal to minus 1. So let's test that. 3 over 4 multiplied by minus 4 over 3. You can stick that into your calculator, or you can just cross multiply. So we'll have, or multiply top by my bottom. So we'll have 3 by minus 4 gives you minus 12. 4 by 3 gives you 12. Minus 12 divided by 12 gives you minus 1. So this equals minus 1. Therefore, perpendicular. Therefore, circumcenter is on the line AC. Now, find the equation of the circumcircle of the triangle ABC. So what do I need? For the equation of a circle, it's going to be x minus h squared plus y minus k squared is equal to r squared. So I need the radius and I need the center. Well, my radius, if we look back up here, if the center of it lies on this line right here, my midpoint is going to be right here. So if I find the distance from here to here, or if I just find the distance overall and divide it by 2, that'll give me the radius. And then all we need is the center, which is going to be midway between A and C. So I have my midpoint, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And if it's on AC, this is going to be the same as x1 plus x2 is 8 minus 3. And then we'll have 4 plus 2. So this simplifies down to 2.5, comma 3. Now we need to find my distance and divide by 2. So if I find the length of AC, well, this is just going to be equal to x2 minus x1 squared plus y2 minus y1 squared minus square root, which is going to be that. So we need AC, so it's going to be minus 3 minus 8, and then it'll be 2 minus 4. Stick that all into your calculator. And we get 5 root 5. And then to find the radius, we need to divide this by 2. So this is going to be my radius. So now I have my center, and I have my radius, so I just fill out the formula. So it's going to be x minus my x value for the center, which is minus 2.5 squared, plus y minus 3 squared is equal to 5 root 5 over 2 squared. And now we just need to expand the brackets because we need to have it in this form, and that's going to be our answer. So if we do that, we're going to get x squared 2.5 or minus 2.5 times x gives you minus 2.5x. We're going to get minus 5x because there's going to be 2 of them. And then we're going to have minus 2.5 squared. It's 25 over 4. And then we're going to have to add on y squared plus 9 minus 6y. And this is going to be equal to 125 over 4. It doesn't want fractions, so now we take away this from both sides and we'll simplify it out. So this is then going to be equal to x squared plus y squared minus 5x minus 6y. So plus 25 over 4, take away minus 125 over 4, well, that's just going to give you 25. Or sorry, minus 25. And then if we add 9 onto it, we're going to be left with minus 16 is equal to 0. So this right here is your answer. It's all about just breaking down the question. What do I need to find the equation of a circle? Well, it's going to be this equation right here. What do I need? I need my center. What is the center? It's the midpoint of AC. And then I need my radius, which is this. Plug everything back in, simplify, and that's what you get. Finally, it says, a different circle, C, has a radius of 5 and a center at minus 3, 1. J is a horizontal line and K is a vertical line. The lines J and K are both tangents to the circle C. Find one possible equation of the line J and one possible equation of the line K. So, this makes a little bit more sense if we graph it out. So, if we graph this out, this is where we're going to get. Our radius is going to be 5 because you go 1, 2, 3, 4, 5. It's going to go like that in all directions. So, we need to figure out what this point is, because it says it's going to be a tangent. And then we also need to figure out this point, and this point right here. So we know that it goes 5 in every direction. So if we move the point minus 3, 1 to the right, all we're going to get is the point 2, 1. So this x value is equal to 2. If we do it the other way, this x value is going to equal minus 8, because we get the point minus 8, 1. If we move it up 5, we're going to get the point minus 3, 6. So this is going to be y is equal to 6. And down here, we're going to move it down 5, so it's going to be minus 3, minus 4. Otherwise, right here, we have y is equal to minus 4. So, these are going to be our answers. J is going to be the horizontal lines, so it's going to be this one here and this one here. So it's going to be y is equal to minus 4 or y is equal to 6. And then K are the vertical lines, so it's this line here and this line here. So x is equal to 2 or x is equal to minus 8. And that's how you get that one done there. So question 4. It says the circle C has equation x minus h squared plus y plus 3 squared is equal to 12, where h is a real number. Write down the center and radius of the circle C. Give your answer in terms of h where appropriate. The only way we can write h in this question is going to be where the center point is. So right here, I know that my center for the x value is 5, and for here, for the y value is minus 3. So my center is going to be h minus 3. My radius, well in this formula, this is r squared. So if I find the square root of 12, that's going to be it. So I'm going to find root 12 is equal to r. Otherwise, my radius is 2 root 3. Part 2. It says the perpendicular distance from the line x minus 4y plus 7 is equal to 0 to the center of C is 5 units. Work out two possible values of h. Give you each answer in third form. So because we're using perpendicular distance, we're going to have to use the perpendicular distance formula, which is going to be this one right here. And then we're just going to plug everything in and see what we get out. So my x1 and y1 are going to be the center of the circle, which is equal to h and minus 3. And then my a, b, and c are going to be the points, or the coefficients of x, y, and then whatever the constant c is. So if you look here, this is going to be my a, this is my b, and this is my c. It tells us that the perpendicular distance is going to be 5 units. So if we go ahead and fill this out, we have a, which is 1, multiplied by my x1 value, which is h. Now we add on b, which is minus 4, multiplied by my y1 value, which is minus 3, plus whatever my c is, which is 7. It's going to be the absolute value of that, and it's divided by the square root of a squared plus b squared, which is 1 squared plus minus 4 squared. And this has to equal 5 units. So if we simplify this, we're going to get h plus 12 plus 7, so h plus 19. And it's going to be all over the square root of 17. And it's going to be equal to 5. Now multiply both sides by the square root of 17. So we get h plus 19 is equal to 5 root 17. And this is how we find our two values. So this can happen either plus or minus. So if we square both sides, we're going to h plus 19 squared is equal to 5 root 17 squared. Otherwise, we get h squared plus 38h plus 361 is equal to 425. Now we just simplify. We're going to get h squared plus 38h minus 64. And if we use our minus b formula, we're going to end up with minus 38 plus or minus the square root of 38 squared minus 4 times minus 64 times 1 divided by 2 times 1. We get two values for this, and these are going to be our two distances. So if we do plus, we're going to end up with minus 19 plus 5 root 17. And if we do minus, we're going to get minus 19 minus 5 root 17. So they're going to be our two answers and our two possible values of h. These two complicated looking things right here.